Welcome everyone. This is going to be the first of many videos for Chem 3330. This is the first semester physical chemistry course here at Texas State, where we'll be covering thermodynamics and electrochemistry. So before we kind of get started in a lot of those topics, I like to start this semester with reviewing just some math concepts and things like that, right? Because some of us have maybe taken these math courses a while ago, don't remember them. Some of us maybe didn't feel very confident in them in the first place. And so I just want to review some concepts and some aspects of math that will appear in this course, right? Physical chemistry, right, is kind of the merging of physics, chemistry, and math, right? And so there will require some math, in the problems involved in this course. And so we'll start today with reviewing some of that math. In this first video, we'll just talk about some basic algebra, things like that, remind ourselves about some of these things, okay? Throughout the semester, we'll be using algebra and calculus and things of that nature, right? And I don't want it to be something that causes us to lose sight of what we're trying to discuss in terms of the chemistry applications and the chemical problems, right? There's often an issue in classes like physical chemistry where students will get kind of stuck on the math and lose sight of the bigger picture. We need to use the math in solving problems, right? Essentially, a lot of problems that are involved in physical chemistry is some system, some setup, some scenario. We have to translate kind of what's going on in the real world into some sort of mathematical relationship, some set of mathematical equations. You then need to manipulate those mathematical equations and solve for whatever it is you want to solve for, and then interpret that solution back to what's going on in the real world, right? And so I very much want us to be able to feel comfortable going from this real world problem setup to what are the set of equations we need, and being able to interpret the answers to those equations. But if people don't feel overly confident of solving those equations, that's not going to drastically impact your grade in this class. It's not going to drastically impact how you perform here. It will impact some, right? Math will be on tests and quizzes and other things like that, but it's not going to be the majority of what I'm trying to test, what I'm trying to make sure you understand, okay? So I'm saying all this to just say, I hope that this review will help people feel more confident, but if you don't feel super confident, don't stress too much about it. Please come talk to me, please come see me and other things, but also try to focus on what physical concepts we're trying to discuss and how that relates to chemistry and such. All right, so in the review that we'll talk about over a course of a couple of videos, talk about some algebra stuff, talk about derivatives, functions, integrals, and things of that nature. Okay, so just some basic review of things with algebra, right? Some just basic concepts of orders of operations, right? When you have things like this multiplied together here, you multiply them out and you'll get 4 separate terms and things of that nature, right? Right, and then some reminders of what happens with fractions, right? So kind of key that, often we can forget that if I have a fraction a plus c divided by b, it's the same as a divided by b plus c divided by b. Similarly, if I am dividing two fractions from each other, I have a divided by b divided by c divided by d, right? That this is the same thing as writing a divided by b times d divided by c, right? If you have a fraction in the denominator of a division, right, you can take the reciprocal of that fraction and multiply by it, okay? So this term here simplifies down to a d over b c. Okay. Similarly, some reminders of exponents, right? Anything raised to the 0 power is always equal to 1, right? If anything's raised to a negative power, it's just going to be 1 divided by that thing, right? That means it's in the denominator of a fraction, okay? Right? 2 to the minus 1 power is equal to 1 over 2, right? You know, a to the 1 over n is the nth root of that number, okay? And then some things with powers, right? If I have the same base here, a, and I multiplied a to the r times a to the s, it's the same thing as a to the r plus s, okay? And similarly, a to the r divided by a to the s is the same as a r minus s. And then if I have something like this, where I have a to the r, and that's raised to the s power, then that's actually a to the r times s. Such, right? Okay, for exponentials and logarithms, right? Exponentials is, right, we just talked about dealing with exponents and powers, right? Exponentials is just that your base is the exponential function e, right? E is just a number, it's 2.7, 2.17, something, I don't know, right? So, right, e is the same thing, if you will, as like pi, right? It's just some number, some irrational number, right? So exponents, right, is just that base raised to some power, follows the same set of rules we talked about, right? Then there are things like logarithms or natural logs here, right? So ln is the natural log, so log base e. Typically, the logarithm function is thought of as log base 10, right? So log of some number x, right, is this log base 10, okay? So some properties of the logarithm function with exponential, things like that, right? This natural log function is the like inverse function, if you will, of the exponential. So ln of e to the x is just equal to x. And then you can solve for that using this relationship down here of ln of x to the y is the same thing as y times ln of x, okay? And the fact that ln of e equals 1, you can use this relationship and the relationship down there to get this guy up here, right? Similarly with logarithms, if you multiply the things inside the logarithm, it's the same thing as adding ln of those two numbers separately. And the division of two numbers inside a logarithm is the same thing as the subtraction, okay?